Okay, let us take this graph again. On y axis we have, and on x axis we have labor input, okay, and of course we are taking capital as fixed. So, we are not putting capital on any axis. So, what we have here is that output is going up as labor is increasing till this point, and then it starts decreasing. That is why when we say, when we talk about production function, we draw here this function in dotted line. Why? Because production function gives the maximum output possible, okay, given the amount of input, and we are allowed to freely dispose of as one of the assumptions and one of the properties that we have talked about earlier, that if let us say we are here, of course, if we are here and if we take this function, it gives the production level as this much, while we can produce a higher output by freely disposing of some of the labor input. So, that is why if we want to talk about the production function, it should be like this, okay, but that is not the point. Now, here we are talking about, if we take this point, just arbitrarily I am taking a point just to remind you, if we draw a line from origin to this point on the output curve, the slope of this line is equal to average product of labor. Why? Because this is Q at this point and this is L, and average product of labor is Q by L. But if we take the slope of this output curve at this point, okay, then what is this? The slope is equal to partial derivative of Q with respect to L, and this is nothing but marginal product of labor. So, on this curve at any point, if we have this curve, we can figure out APL as well as MPL, although here the process is reversed. We already knew APL and MPL, and using that we had drawn this curve. But what I am saying, when you have an output curve with respect to one of the inputs, we can always figure out average product with respect to that input, and that input here is labor, and of course also we can figure out marginal product of labor. Fine. And if you notice at till this point, that average product of labor is increasing, okay, it is increasing, and after this point it starts decreasing. Fine. Okay. Now, what we can do, we take another graph where L is still on x axis, but on y axis we are not plotting Q, but we plot APL and MPL, two different curves. So, what is happening till this point, if we just take, of course it is rough, it is not very exact. What is happening till this point, average product of labor is increasing, and after this point it starts decreasing. And if we see the value of MPL at this point, if you look at the value, that is labor input labor is equal to 1, APL and MPL both are equal, but at this point rate of increase of MPL is higher than rate of increase of APL, or in other word, MPL is increasing at faster rate than APL. So, it goes up and then it starts coming down. Again, it is not to the scale, it is very rough. What is remarkable is here at the point where APL is highest, the maximum, at that point MPL curve cuts the APL curve from above. That is also very important, from above. Okay. So, is it because the way I have given the, I have put the value, the way I have given the table, or it's true all the time that wherever APL is maximized, MPL is equal to APL.
It's true all the time.
It's true all the time. Why? If you just look at it, let's say average product of capital is 2 and marginal product of capital at that point is 3. What does it mean? That if you add one more unit of labor, increase in output because of this new labor would be equal to 3, while average is 2. Of course, 3 is greater than 2. So, in numerator you are adding 1, and in as a result in denominator you are adding 1, but in numerator as a result 3 is being added, and that is of course more than 2. So, average per person would go up. Okay. So, this what you can say 3 minus 2 1 will be distributed over all the labor. So, for everyone average, for every average contribution would go up from 2 to 2 plus 1 by L.
So, we can also say this by the way that when average is maximum, it means we are adding something to it which makes it maximum, and after that it will decrease. So, at that point of time, MPL, that is the del change in labor, should be less than average, should be less than the average, else it will increase again. I mean,
no, but I am talking about in general at all the points.
I am saying for all the points, sir. Like whenever average is maximum.
Not whenever average is maximum.
Average is maximum. After
so,
that,
when you are saying average is maximum at only one point. Let's look at it here. Average is maximum only at this point,
yes,
not
sir.
everywhere.
So, sir,
but we are talking about all the positions where MPL, that is marginal product of labor, is greater than average product of labor.
Sir, what I am saying is that MPL should cut the APL graph at that point. I am saying the reason for that. It is because the average is maximum. That means we are adding something in that average which is maximum, which has made it maximum, and the rest of the things are lesser than that term. That is why the average is decreasing after
for
that.
Maximum, what you are saying
Yes,
is
sir.
true, but in general it's true for all the point that whenever MPL is greater than APL, on average it is adding, average contribution of all the labors are going up. That's why average product of labor will increase.
Yes, sir. So
Okay, and
every new labor is better than the previous labor.
not better than, the incremental contribution is more than the average contribution of all the previous workers. And that's why the new workers contribution would add on the average contribution of all the other workers, and that's why average product of labor will increase. Okay, and similarly here marginal product of labor is, whenever you have marginal product of labor less than, average product of labor, what will happen? Again the incremental contribution is less than the average. That's why it would decrease the average of all the workers, and thus average product of labor will start decreasing. So, when maximum, what does it mean? Maximum is a kind of a stationary point. At maximum, you know, at which point the average product of labor is maximized, where this is one of the requirement, that average product of labor should be stationary. So, when it can be stationary? When it will not change, where it is equal to marginal product of labor. That's why at maximum average marginal product of labor curve intersects the average product of labor curve. Now, the another point is why it should cut the average product curve from above, not from below. What I mean, see, there are two intersection point, one is here and one is here. Okay, two green. So, at this point also average product of labor is equal to marginal product of labor, and at this point also average product of labor is equal to marginal product of labor. That's why we need to specify what is the difference between at this point and this point. Here marginal product of labor curve is cutting average product of labor curve from below. So, when L is increasing, it is moving like this, average product of curve is like this and marginal product curve is like this. So, it is cutting from below, while here it is opposite, okay? It is cutting from above. So, that is another requirement. Why it should be cutting from above?
Sir, because initially, like we said, that diminishing marginal product of labor, if the marginal product of labor is diminishing and we keep on adding labor, then marginal product of labor could
That's look at it little bit mathematically. See what's happening where
So-
it's cutting.
Like you said, including the criteria of free disposing, when we have obtained,
It has nothing to
Sir,
do
when
with
we
free
obta-
disposing.
When we obtained, like we using the computer example, when we have 7 people for 7 computers, and when
No,
we,
I'm not saying for the specific example. What's happening in general? Let's look at where it's cutting from below. Okay, here it's cutting from below. What's happening it here? That beyond this point, MPL is above APL. Okay, so it means that what will be its impact? We have just discussed that APL will increase. APL will increase. So, if APL is increasing by increasing labor, it cannot attain maximum here. Fine. While what's happening here? Here it's cutting from sorry.
Is it possible for MPL to cut this from below?
Here it is cutting from here.
But
It's
since APL is just sum of MPLs of n things, so if MPL is cutting from below, that means its sum will.
MPL is not sum of all the
So
APLs.
it's just.
It's not. It is not. Let me just tell you, clarify it to you. Here is total quantity curve. Okay, here is the total. When what we are doing is, here we have Q, here we have L. Okay, fine. And what is APL? APL is, let us say APL at this point. APL at this point is this angle, because here we have Q, here we have L at this level. So, at L naught, APL is Q naught by L naught. In other word, the slope of this line. Okay. And what is MPL? MPL is slope at this point. So, MPL is not integration of APL. MPL is at this point at L is equal to L naught. Is it clear? Fine. Now, it is clear why it has to cut from above.
Yes, sir.
Because that is the stationary, you can't get the stationary point if it cuts the APL from below. Fine, and that is the reason. So, two requirements. One that is where APL is maximized, max APL should be equal to MPL, fine, and MPL curve should cut APL curve from above. If you know calculus, you would notice that this is basically first order condition and this is second order condition. Let us look at it, let us do it mathematically. Okay. What is APL? Q by L. Fine. Let us differentiate the APL. What do we mean by that? If L increases, APL increases. What does it mean? it means that the derivative of APL with respect to L is positive. That is what it means. So, let us say we have only one variable.
इस case में
What can we write it?
इधर side
What can we write it? This is nothing but
q by L square minus q by L square plus dq by dl into 1 by L.
this is q by L square. You can say put partial derivative sign, thinking that there may be more than one input. Fine. Is it clear? Take 1 by L common. And as a result, what would you get? 1 by L, and what is this?
MPL.
This is MPL at that point. And what is this?
APL.
APL. Just leave it here. So, now it is very clear, if MPL is greater than APL, what it means? That partial derivative of APL with respect to labor is greater than 0. It means L goes up,
APL goes up.
APL goes up. Fine. Is it clear? Okay. Now, if MPL is less than APL, what it means? The partial derivative of average product of labor with respect to labor is negative, and it implies L goes up, APL
Comes down.
goes down, and third would be MPL is equal to APL, and that is how we get the
Maximum.
stationary point.
Extremum.
L goes up momentarily, not at all level, just at that point that L goes up, APL remains the same, no change. Remember, if you know calculus, although we have already discussed the graphically, but using calculus it just helps you get little more information. So, what is really happening? That this is one of the requirement, okay, that MPL is equal to APL, then APL may have maximum or minimum or one of the critical points, the boundary points. Okay, fine. So, we cannot say that it would be the maximum. What we have learned? We have learned that there are 2 points where they are equal, this point and this point, but only here we have maximum. The second requirement that I am not going to discuss, but if you know calculus, we have obtained the first order condition, you can obtain the second order condition. And how can you obtain the second order condition? Just let me tell you how you can obtain the second order condition. Differentiate average product of labor with respect to labor twice, not just once. So, now what you need to do is, you need to obtain this, and this will give you the second order condition. The interpretation, the graphical interpretation would be, the requirement that it gives you would be just that MPL curve should cut the APL curve from above. Fine? It is clear? Okay. It is very, very important. And also you should not get confused, because this is the common mistake when people say, what if MPL is decreasing? What would happen to the APL? Can you say that? Let us say that MPL is decreasing, what would happen to APL? We cannot make any comment. Why? Because let us look at this zone. Here in this zone, MPL is decreasing, but APL is increasing, and in this zone MPL is decreasing and APL is also decreasing. So, we cannot say anything about it. We can comment about APL given the information about MPL only when we can compare the values of MPL and APL. Okay? So, be very wary about this. Is typical question that you get in exam. Okay? Fine.